How's it going? I see the chat already going crazy. That is awesome, y'all. I saw Yash pop in as well. Hi, Yash. I see so many people here saying hi. Hello, everyone. Hi, Yash. There we go. There's Yash. And this time I came back to streams. In case y'all are joining us for the first time, I have been known to take a ton of streams. And yeah, this is fun. Let's how do I make this full screen? Give me 1 second, folks. Never mind. Let me bring the brand back. Okay, give me 1 second. Over there. There we go. All right, this is much better. No worries, Yash. Go on. Please be careful while walking on the street. Yes, it is a workshop in the background. I have like tons of tools, I have like tons of materials. I keep doing crazy stuff, but I'll tell you more about it in my introduction. But I see some amazing folks here, and that is so awesome. I always, there's like some of these streams because they're slightly more Oh no, you're not late, Tej. You're absolutely on time. We're just getting started. And these things can be a little difficult to follow when you're not doing them, in person yourself, especially when it comes to electronics. Hang in there. I have some fun activities for y'all. We're going to be actually making circuits as we learn about things. So it's going to be fun, hopefully. But so here's what I've done. Today's session is a fairly open session, so we're just going to try some things, see how they work, and then from the next session, we'll have a slightly more structured theme where y'all have decided how you want to go about it, right? So I have some fun treasure hunts planned for you. When I say treasure hunts, that means I'm going to be asking you to go around the house and look for things. Then we're going to have some analogy contests, and yeah, you never know, if y'all are good enough, I might just send you some microcontrollers myself. All right, so let's get started. First of all, if y'all are here, that means y'all, yes, I'll definitely send you some controllers. But if y'all are here, that means y'all deserve some swag, especially, consideration for the bonus swag. So definitely check in and register for this event. I'm going to send the link. Well, thank you, Salad Mama. I do love my background. It's so real, I guess. But yeah, I'm actually planning to take a picture of this and use it as an actual background too. If y'all want it, let me know, and I'm happy to share it. Y'all can have the same background as me. Awesome. Ayusha's already checked in and registered. Again, y'all are here. Y'all deserve the swag, so make sure y'all check in. And yep, we're gonna have some fun challenges. It's gonna be more of an open discussion today because we're just gonna see how much we all know, and then that's when the point we're gonna start really learning about things, right? And we have 3 streams consecutively, so today, tomorrow, and day after, based on the same thing. Friday is a very interesting stream where we're going to do some art with Touch Designer in Python. So that should be fun. But yeah, today it's going to be fun. I'm going to show you some transistors, capacitors, resistors. That's how basic we're going to start. We're going to make some simple circuits. I'm going to ask you all to send pictures of the circuits because, well, again, why not, right? And we're going to have some analogy contests. So that's going to be fun. All right, let's dive right in. And I'm going to just quickly pull up my slides and share. Mm, And it's going to be a bit. Give me 1 second, folks. My slides is hanging up. and share. And there we go. Is my screen visible just yet? All right. So we are about to start. Thank you, Salad Mama, for confirming. Yes, we are about to start and keep the questions going. I usually do this nice icebreaker. So we're going to do that icebreaker as well. And you know what happens is during the icebreaker, we just end up going over so many concepts that it becomes really easy to follow through. But let's get started with me. Hi everyone, I'm Rithvi, and I'm a coach at Major League Hacking with really bad lighting right now because yeah, initially when I did streams, I used to do them all in the evening, so the light used to be the right kind. But I'm going to be rearranging it for the next streams as I've learned. But yeah, so I'm a coach at Major League Hacking. I've been so for over a year. Even though I completed almost a quarter more than a year now. This is exactly a year ago that I started doing streams. I started around exactly the same time last year, and it was amazing. I got an amazing response for IoT, and I do IoT streams a lot, but I've realized that IoT can be a very difficult topic to just take on, and your understanding is very vague when you don't know the basics. So since this is beginners week, we've come back a step, and we're going to be learning right from the basics, and then in the next stream, if you all want, I'll go back to doing IoT and we'll just pick up from where we left off in this stream session. All right. I'm a maker, as you all already noticed my background. I love doing maker stuff. If you all want to check out my creations no more, I'm not that great at posting stuff on my social media, but if you all do want to know more, let me know. I'm happy to share it in the next stream, right? I'm a hardware fanatic, as you all can tell. I love doing hardware streams, IoT streams, and anything on those lines. And currently, I work as a community manager at Blues Wireless. All right, so these are the things that we will be covering. But before we get started, right, these are the things that we'll go over anyway, right? Circuit analysis is maybe not something we'll do today, tomorrow, but we'll definitely do our own circuits today. So before that, though, what is the first thing that comes to your head when someone says electronics? What's the first thing you think of? It can be anything, right? This is an intuition game that I like to play. That way, you know that you already know a lot. We're just gonna, fine tune out. We're gonna tune out the threads of what you all already know, right? So just whatever comes to your head. If it's a device, if it's a concept, if it's a teacher, just come on. I'm looking at the chat, and whatever comes to your head when you think of electronics. For example, when I think of electronics, there we go. The first answer from It's Me Hub Motors Wires, which is awesome. Great job. Wires, that's amazing way. I love how that's such a universal answer too. You didn't like circuit analysis, Rihan. I'll make sure that you really learn to like it now. You'll love circuit analysis after this. Mobile, that is awesome. Registers, that is very specific and an amazing answer. Boards, awesome. Ayush, shocks. Well, hopefully not, Nan. And I have a feeling there's a story behind it, and I would love to know more about why you associate electronics with shocks. Transistors, great answer. All electronic devices. Waves. I like this answer, Priyanka. I really like this answer. PCBs. Awesome. That is a great answer. So PCBs. So the reason. So I'll let your story on PCBs later. But LEDs. Great answer again. Electrons. Again, very universal answer, just like wires. All right, I'm gonna give you all another 30 seconds if there's any any associations that you all are making or getting back to me with. I like this association. You know what? This is a great way to associate any technical topic really. Emulate streams. This is great. Raspberry Pi, another great answer. All right, we're gonna do this for another minute. Y'all can answer as many times as you like. Oh my god, analog system design. That went complex very fast. Insects. I am very curious about how you think insects over here. If you're thinking about insects, like those tiny robots that people are making these days, I want to say you all are correct, but not entirely. Okay, folks, no more answers. Jetson Nano, another good answer. They mean nice. Thank you again, Hunan. Great answers. Tony Stark. Oh, that's a good association. I like connecting stuff to sci-fi as well. Awesome, folks. Y'all have been amazing. This is great. I have never seen so many answers come into this question before. But we're gonna keep going, right? As we cover components, as we do more and more, analysis, not circuit analysis per se, but more like we go around looking for things. You'll realize how connected they are. That is a really detailed answer. Thank you, Wombo Combo. Awesome. That is amazing. So if there are no more answers, let's start talking about what electronics really is. So here's the fun part, right? How is electronics different from electrical? Anyone has the answer? Why is electronics and electrical engineering so different? No one? Okay, fun. So electronics and electrical engineering initially when it was started, right? How electronics came to be was anything lower than 12 volts, 5 volts, you know, gets qualified into electronics, and anything above that gets electrical, right? Yes, Salad Mama, that's a great observation. Most of your electronic circuits can be digital circuits, or they come across as digital circuits, but they really aren't, right? So one another good differentiation between electronics and electrical is that you can say that most, again, this is an observed difference, this is not a non-paper difference, but like if you observe around most of your electronic devices, they run on DC circuits, right? So the power always constant, unlike your electricals, which almost always run directly on AC circuits. Now you might argue that you're connecting your adapter to the AC circuit, but that's the whole point. That's why you need an adapter, right? Unlike your light bulb, which directly goes into the your electrical wiring of the house, right? So that's some of the basics observed difference between electrical and electronics. So let's see, is your light bulb an electronic or an electrical device? Would you qualify your light bulb attached as an electrical or an electronic device? Electric, awesome way. But wait, here's the question for you. What about your Wi-Fi controlled light bulbs? Are they electronic or electrical? Awesome, Kaustubh. Same question for you. Hi there, Ayush. Awesome. Well, Kaustubh's initial answer was right. Light bulb alone, your light bulb itself, is an electrical device. But every time you can always add on circuits, so this just the circuit controlling and connecting it to the Wi-Fi is electronic, right? Exactly, it's a combo. And these days most of our devices, they cannot be just you can't call it device itself electronic or electrical. You need to break it down, which is why being able to observe the components and identify the components is fairly important. Awesome, folks. Great start. So let's start with something very simple, right? Let's start with something very basic. Passive components, active components. First, you all know the difference between electrical and electronics. So now when you look at a system, you'll be able to tell that, okay, my TV is being controlled, is getting AC power, and it has somewhere inside the circuit where the AC power is probably being directly used at some point. But there's an entire circuit inside which is electronics, which is giving it its smart device usage. right? The same applies to your washing machines, right? I mean, they have been electrical devices forever, but now there's a huge part of electronic component coming into being, right? Your smart valves and whatnot, right? So we'll look at some solenoids as well, how there are AC solenoids and DC solenoids and things like that. All right, and what's different about them. But today is very basic. Again, it's an open discussion. It's about getting to speed about who knows how much, and then we'll be very specific and then develop very specifically. All right, so let's dive into the next thing, which is the building blocks of your electronics, right? So just like any other thing that you learn, whether it's JavaScript, any language, any framework, there are some tiny things or tiny Lego blocks that make up the entire framework, right? So let's say you make a front end page. There are tons of layers and tons of blocks that you're adding, right? First, you're adding the server connection, then you're adding these tiny buttons, then you're linking the buttons to the links. These are these tiny blocks that you're linking together to form a huge thing, right? Now they all have their own characteristics, right? Some of them are common across frameworks, across languages, some are unique to the frameworks, and the same applies to electronics. Hi Ashish, I'm so glad you can join us today. So Ashish and Yash are some of my most, common and regular attendees of streams, and I'm so glad both of them could join today. All right. So, right, same way electronics has its blocks too, and every time you're creating a certain controller, a certain application or project with it, you can build them up like blocks, right? For example, let's say you want to control a light bulb with a switch. So now you know that you need a bulb, an LED, for sake of simplicity, an LED. Then you need a switch. Then you need a resistor, right? So these are blocks, and you imagine them because now you know that okay, a switch does this, a resistor does this, and a LED needs this, right? So now we're going to at how these components come together and how they're different and how you can kind of inter change them with each other, right? For example, an example of what you might want to do is change your switch to an auto, a switch that kind of is a sensor also. So what if you don't want a manual switch but a switch to change its position when a certain thing in your circuit changes? That's when you use a transistor or a MOSFET, right? So these are the things that we'll be looking at eventually. Again, this is today is a very chill session. Y'all can ask me any questions. Y'all can tell me, okay, this is too confusing, start even more from the beginning. We'll do that. All right. Thank you, Ashish. Please go back to your lab. I really would hate to get you in trouble in college because of a stream. Oh yeah. I'll display my socials in a bit. Let me just quickly. I'll bring up banner in a bit. But yeah, this is exciting, Kaustav. This is very exciting. It's gonna be fun today. It's a very chill session, right? And we're gonna start making some circuits in like 10 more minutes, right? Awesome. Great. So I see a lot more people having dropped in. Hi Anurag. Hi G3TTIS. Getis? Is that how you pronounce it? I'm not sure. All right. So let's start with our building blocks. Our first building blocks for any circuit you pick up, you'll always find this building block because these are very chill components. They don't really care about. They're the couch potatoes. They have a certain value. They stay a certain way, and they don't care how you're using them. If you don't use them right, they'll blow up. But they're not gonna change for you. All right. So these building blocks, which every circuit has, you cannot imagine a circuit without them, are called passive components. So, can you all give me examples of passive components? Or rather, let's do it over again, right? What comes to your mind when I say passive components? Thank you, A. Jackson. Correct. Resistors are a great example of passive components. Anything else, whatever comes to your head. It does not have to be an actual component. Whatever comes to your head when I say a passive component. Awesome. Resistor, capacitors, inductors. Awesome. Capacitors, great job. LED, is LED a passive component? Can anyone tell me if LED is a passive component? Awesome. All right, so I'm gonna let the answers come in, but until then, can someone tell me how a passive component is different, or how a passive component is different from an active component? I just gave a really good definition and analogy, right? All right, so great answers, everyone. So here's the next question for you. I just gave a great analogy for what an passive component is, right? I told you they're basically couch potatoes. They're gonna stay the same way no matter what you do. You move them too much, they're just gonna blow up. They'll probably, they want too much. You give them power, great. If not, they're just sitting there. They're not harming anything. What do you need me to repeat, Ashar? So an example of analogies is basically, if I tell you the definition, you come up with something else that does something similar, right? It's like a metaphor, but more to the point, right? Transistor is an active component. Microcontrollers are an active component, yes. Oh, sure. So passive components, I'm actually waiting for the definition from you all. What are passive components? So passive components are basically like couch potatoes, Asha. That's what I said. They don't really have a reaction. Rather, they have a certain point. They have a certain behavior, and they stay that way. They don't change their behavior for anything or anyone. You connect them, you trouble them too much, they will blow up. Oh, which are passive? Passives are inductors, capacitors, and resistors, as very mentioned by a lot of folks over here. So I want you all to give me an analogy of a passive component. Exactly. Doesn't move is a good way to put it. Yes. Anyone? Any example? Any your favorite toy? Your favorite show? Favorite character? Any in any show? No, no analogies. Nothing that reminds you of passive components. I won't call Tony Stark a passive component, which takes a lot of inputs. I like the thought, but folks, can I lay a little more thought into this? A wall. I love this example. Thank you very much. Yes, something similar to a wall. Background characters. You know what? You're actually very right in a different way. Not really. But let's see. I don't understand this an analogy. Non-playable characters. Great example. A spring, yes, that's actually a very good example of what we're gonna, look at capacitors and resistors. I am sorry. I have barely any knowledge for machine learning, but I'll give you this. The thought really is nice. Great. That's a really good example. You stole my example. All right, folks. Those are Amazing examples. I loved them. I loved the analogies that you all came up with. And we're going to keep this up, okay? In the end, I want you all to take the favorite topic that you'll, favorite word that you learned, right? Passive components, resistors, capacitors, and post your favorite analogy. Come up with your own analogy and post it on Twitter, all right? And tag me, and then I'll definitely keep an eye out. In the three streams, I'll definitely send out a microcontroller to one of you all. Okay? Awesome. Great job. Let's dive into passive components. So what are passive components? Let me quickly walk you through what exactly is a passive component, right? So first of all the examples you gave are very correct, right? But so I'm gonna walk you through some simple things of what are passive components, right? So I have some notes. I'm gonna just read them out to you. Okay. So passive devices utilize power or energy into a circuit. All right. They do not give power to the circuit. They utilize it. They use the power. All right. At no point, again, like we said, right? They're not really movers. They're the kind of the people you keep pushing, they'll do stuff. At some point they're gonna break, right? Examples, as you all gave very rightly: resistors, inductors, capacitors. Now anything that uses these components to become something, for example a motor, right? These all are passive components. They're utilizing the power. Make sense? Exactly. They utilize it, store it. At some point they'll break, but they basically utilize it, right? They do not provide any kind of function to the power gain. Again, basically the same thing, right? They're not really battery is not a passive component, right? It's actually the main power source. Hi Shavadeep, welcome back. Another very good way to identify whether something is a active device or not, or a passive device or not, is that a passive All right, am I audible again, folks? I realize I froze for a bit because even my screen completely disappeared. Awesome. Yes, network issue. It is Shivadeep. I did welcome you. I hope you heard that. But awesome. Since you all are back, so does this everyone understand a passive component now? So motors, switches, as very rightly someone also again mentioned in the thing, they basically do not control the current. They cannot change the flow of the current. And when I say change the flow of the current, as in you can control the current with them, but you cannot change the number, as in you cannot increase it. You can't amplify it. Make sense? So for example, an amplifier very obviously amplifies either the voltage or the current, right? But a resistor can use it to slow down the current, but at no point are you actually changing the original current value. Unlike, of course, a active component, which can obviously actually change the value of the power in the circuit. And why I use power is because power is obviously a multiplication of the voltage and current in a way, right? No, folks, it was my internet. Come on, Ashish knows I don't have great internet. I live in the suburbs of suburbs, so I don't have the best internet. But we make do. Hackers are pretty nice to me for the most part. All right, does that make sense, folks? So now it's going to be something more fun. All right, are you all ready? Are you all ready for the activity? They don't keep it constant, salad mama. What they cannot do is increase it, because you can always use passive. So what passive components ideally do is they help you control the things in the circuit already. They remember they're accepting power, they're using the power, so they'll probably reduce the power a little. So if you remember, the power's formula, if anyone remembers, is v square by r also. So they are responsible for the power, but they're not responsible for amplifying or changing the value of the devices or the current in your circuit, right? They're a medium, exactly. What a beautiful way to put it. Thank you, Wombo Combo. Make sense? All right, so fun time now. Okay, I'm gonna ask you to go around the house and find me these components. They do not have to be part of a circuit, right? Remember, even a transformer is actually a passive component. It's doing nothing on its own. All right, a stabilizer. Yes, a stabilizer, but again, a stabilizer is a fairly complicated circuit, right? There are multiple components in it. Fan, beautiful example, Rihan. It's a motor. That's how you know it's a passive component. Motors are passive components because they're basically your coils wound around, right? So great job. Now I want you to go around your house very quickly. It's 11:08 on my clock, right? 11:10, 11:11. I want you all back with pictures of your passive components, and I know you all can't post it on StreamYard, so let's go on Discord and post our passive components. Go in your guilds and post it. I want you all to go in your guilds and post your passive components pictures. Oh, I'm sure your library has a fan, Rihan. You only gave an great example. Come on. Switches, fans. Let's see if people can find new places where there might be just motors. That's okay. But yeah, so that's okay. Take a picture of a fan and post it in your guild. Let's see. You all post. Or if you all want to go ahead and tweet, go ahead and do that. But let's post pictures of passive components. So Rihan is posting a picture of a fan, and let's see if you all can go around and find anything different. So I told you transformer is a passive component. Do you all have a transformer in your house? Switches are passive components. Let's see if you all can find any more passive components around you. I am keeping an eye on Discord, and if you're posting in your guild, do tag me so that I know you all have posted about this. Are you all doing it? Arduino is not a passive component. It's an entire circuit. So there are components on it. If you have an Arduino, you can find passive components on it. So let's take a picture. An amplifier is not a passive component way. So no, no, your laptop has an entire PCB circuit in it, which has a lot of components. So if you have some old remote, old device lying around, and if you open it, you'll be able to find a lot of passive and active components on it. So if you can find that, great. But just post it in your guild. Are you part of a guild? If you're not part of a guild, then you can quickly join a guild, but you can post it in Beginners Week Lounge. Post it in Beginners Week Lounge. AC remote is again an entire circuit. So there'll be a lot of components inside the AC remote. Again, an entire PCB. A fan is a passive component because it's only a motor. It's an AC motor, but it's still a passive component because you're just directly putting power into it, right? Same applies to your bulbs, right? Remember, you're just lighting them up. So, yes. Sure, if you can take a picture of that salad, mama, I'll take it. But it's okay, all of y'all can post the same thing. Your mixer grinder, right? If you have a mixer and grinder, there's a motor inside it. That's a passive component. So come on, go around something that is an obvious passive component. Let's you take pictures and post. Oh, great. Mike posted. Awesome, Mike. You are, I think, holding an LED, but that's okay. I'll give you all. Give the thought. The thing. Also, if you all are posting in your guilds, do tag me because I won't know if you all posted or not. Awesome. Rihan posted as well. Well, I'm sure the librarian is looking at you suspiciously right now. What a geezer. Great example, Ashar. Great example. Yes, it's basically a heating rod and it's doing exactly doing similar to what a transformer does. Although it is more of an analogy passive component because again there's an entire circuit behind it, but I like the thinking. I like the thought behind it. No more examples, no more pictures. I thought you'd have fun doing this. It's okay if y'all don't want to do it. Ooh, big, great example. Again, same concept. There's an entire circuit inside there which has a lot of components, but the thought counts. So I'm gonna give way that as well. It's heat. It's a heater component. It's basically not changing anything, but just drawing power. Great example. Great analogy at the very least, right? Because it's just absorbing power. It's not really changing anything apart from that. So good enough. I see three people having posted. I don't see a lot of other folks doing it. All right, no worries. But I'm glad you all participated. I see some great examples and a lot of great thought going in there, which is what counts. If you all do post, do tag me later as well, so that I can definitely consider you for the microcontroller that I give away at the end of the three streams. Salad Mama, you can post in the Beginners Week Lounge in Discord or in your guild. If you're posting it in your guild, do tag me because I wouldn't know otherwise. Where have you posted? Guild, Warrior Guild. Let me check. Warrior Guild. Coding Warrior. Awesome. Thank you so much, Priyanka. Amazing. Y'all are awesome. I see so many pictures still. So, all right. Great job, folks. Let's move on. So, now you all identify passive components. Okay, now let's try using passive components in our circuits, right? So I'm going to be using Tinkercad right now because I actually researched a lot of simulators for you all. The only problem is you can use whatever simulator you want. If you all get stuck, I'll help you all out regardless. The only reason I'm going for Tinkercad is because other simulators are way too detailed in their analysis. And while I would love for you all to try that and understand that, I don't want it to end up becoming a college lecture either, right? So I want it to be fun. I want it to be interactive. So let's go on to Tinkercad. I'm going to post the link to Tinkercad right here so that you all can quickly sign up. And we'll start making our circuits and start making our LEDs blink. All right, so I'm going to give you all another 4 minutes. I think is good enough for everyone to sign up and give me a heads up that they're on Tinkercad. Until then, what I'm going to do is I'm going to start sharing my Tinkercad so that you all know where you want to end up uh, after you create the account. Multitasking is not going great today. All right, so this is what your Tinkercad will look like once you've signed in and are in the circuits section. All right, so let's see you all sign up. Until then, what I am going to do is I'm going to put a banner with my socials. So in case you all want to post your passive components and your analogies, you all can tag me using that. Okay, I see three comments. Give me 1 second, folks. I'm just trying to make the banner. Okay, I can't create banners right now because the banners are full, but yes, create your first circuit design. And if you see if you go to your dashboard, there'll be a new sign on the corner. Let me just show it to you. So if you go to your dashboard right here, right, you should all land on your dashboard. You can go to your circuits and you can click on new and you can click on circuit. And this is what I've created here. So I'm just going to go ahead and click on tinker this. Awesome. Asher's on the same page. So is Anurag. That is awesome. Got it. Awesome. Way. Glad you got it. Now I'm going to go back to try and create the banner again. Huh. All right. So that there you go. These are my socials. I know I don't want to. I want it to be scroll banner. Thank you. And there we go. So this is something for you. Awesome. Anurag's done. Priyanka's done. You want to join the Coding Warrior Guild? To join guilds, you all can just go and join. When you go into MyMLH, you can go and join the guilds. But I would suggest just joining the channel. Let me see if I can help you there. Hmm. So if you go and join my guild, you can just go and ask someone to send you the link to Coding Warriors. I can do that too. I'm not sure if I should. I think the guild leader will let you join. So just let me know if you can't, and then I'll just add you later. All right. This is Costa asking how to join the Coding Warrior Guild. Awesome. So, folks, are we all on the same page? Are we still waiting for a few people to come on the same page? We're going to make a very simple circuit with all passive components and one active component because we need something to give us the power. All right, folks, I'm going to give you all 1 more minute. If you all want me to wait, let me know. If not, we can just get started into making our circuit. So, anyway, since this is going to be recorded, you all can always go back, but let's start making our circuit, right? So, you all can see this is your entire space. There's tons of things over here. You can choose your wire color. There are some good and bad practices that I expect you all to kind of follow through. I see people having tagged me somewhere. Awesome. Salad Mama, that is a lot of effort and I very much appreciate it. So if you all don't know, and I think not all of you can see, Salad Mama actually went and clicked the capacitors picture in the fan, which is very cool. You know what? I'm going to quickly share that. No. That is amazing. I love the dedication. And there we go. So this is what you see. This is so cool. I'm so glad. I'm so glad you all are discovering. This is the fun of it. After this, I promise you, everywhere you go, you're going to be able to observe these things. And Wei has suggested how you can join the guild without me adding you manually. Awesome. So let's go back to our Tinkercad. Share screen. Tinkercad. Awesome. Right. Okay. So there are some good practices and back practices that we'll be covering as we go, right? But let's first start with throwing our components onto the table. So of course, first we have the register, right? So we have name, register, passive, activity 1, I'm going to give it around 1000. 10 kilo ohms is good. So our resistor is 10 kilo ohms. Then we're going to have our LED. Let's throw it in here. I'm going to give it name passive activity 2. And I like a blue LED. So I'm going to go for a blue LED. And done. What do we need more? So we have a resistor, we have an LED, both of them which are passive components. We'll discuss how LED is a passive component. I know one of y'all suggested it, and I asked whether or not it was, and I loved some answers that I got. Uh, oh, y'all didn't see the capacitor that I just shared from Salad Mama? I thought I did share it. Anyway, I'll come back to it once we're done. Oh, I'm not sharing my screen. Ah, I see. Thank you, Salad Mama. Thank you so much. I actually thought I was sharing my screen. Never mind. So anyway, so what I first did was I picked up a resistor, threw it in here, changed the name I'm going to delete this and I'll show you the name that I changed it to. I changed it to passive activity 1, which is my first component of the passive activity. Then I changed my LED, the color to blue, and the name to component 2. All right. And then I'm going to add another passive component, which is my push button. And I'm going to change the name to passive activity component 3. So there we go. This is my third component. So these all are my passive components. All right. Now what I want to do is now I want to add the component that's going to give all the power. Of course, it's going to be the battery. So let's quickly pick up a battery. We don't need a 9-volt battery, so we're going to go with a 3-volt battery. It's good enough. This is going to be our passive activity component 4. Awesome. Okay, so now I'm going to start connecting it. So I'm going to first, arrange them in a way that I know makes sense. So remember, the resistor has no polarity. What do you mean by polarity? That means a resistor, you can connect it anyway, right? A battery has polarity. What do I mean by that? So a battery has a positive and a negative, and the way you connect it will change the way it behaves. A resistor, however, is non-polar, which means that you can connect it anyhow, right? So let's start by connecting first the push button, of course. So let's do terminal 2B. Let's do terminal 1A. All right. Okay. Then we're going to connect the terminal to the anode or the cathode. The anode. And then we're going to connect the cathode to the negative thing. All right. Can I rotate this? I want to rotate this. There we go. Okay. And we have it rotated. All right. So what have I done here? I have literally just connected all the circuit, right? And now you can do the same, but here's how you're going to go about it, right? So your positive battery, the positive end of the battery is where the current starts from. Remember, it's always positive to negative. That's how you connect it. So your positive ends, all of them get connected together. All your negative ends get connected together. There's something called the VCC ground thing that we'll look into in a little bit. All right. But here's what I've done. So I connected the positive end of the LED, which is the anode, the negative end of the LED to the cathode, the negative end of the battery, right? My resistor is non-polar, so it doesn't matter how I connect it. What I did do was I did connect two different terminals of the push button, and it's okay that I've connected two different ends because when I push the button, all four of the ends get shorted. All right. So 1A and 1B are already shorted. 2 and 2B are already shorted. And when I push the button, the entire circuit gets shorted, right? Exactly. The conventional flow direction of the flow. Exactly. Right? So now let's look at what happens when I push the button. So I'm going to start the simulation, right? I'm going to push the button and the LED glows. Awesome. So you all have now, if you all have made this circuit, you all have created your first circuit and you all have learned how to use passive components with one active source. All right. So can anyone tell me how LED is a passive component and not an active component? Remember what a definition of the passive component was. It only absorbs the energy. It does not change the energy or does not contribute to the energy being, uh, is flowing in the circuit. So an LED, which is a diode, is actually a passive component. So your LED is just absorbing, you know, changing its brightness and then giving nothing back to the socket. It's going to absorb some current, absorb some voltage. LED is a voltage powered device, so it's going to absorb some voltage. The current remains constant, and it's going to use up the potential difference of the battery that way. Does that make sense, everyone? Is everyone on the same page? If you all have made this circuit again, this is a huge step, especially if you are not from an electronics background. I want you all to give a pat on yourself and post your first circuit in Discord. I would love to see your circuits, what you all have created. If you all have used multiple LEDs, if you all have played around with the resistance of the resistor. All right, now we're going to look at something called a potentiometer. A potentiometer is one of my favorite devices, one of my favorite passive components. It's because so here's the thing, right? When you're working, especially with simulators, especially in projects or in hackathons, you cannot always get the sensors and the hardware. So what do? You use simulations, right? Now what happens with simulations is you won't find the exact components in every software, right? Especially Tinkercad, right? Now Tinkercad is actually very advanced. So is Wokwi, the other software I usually recommend while using, like microcontrollers. What happens is you cannot always find the right sensor behavior or the right sensor module, because again it's a very corporate thing, right? Why some software has that sensor, why something doesn't. A potentiometer really helps you all emulate sensors. What is a sensor, right? A sensor is basically giving you multiple values, right? Now you can always emulate the sensor with a potentiometer, because a potentiometer can help you change the value of the voltage running through your entire circuit. Because it's what is a potentiometer? Potentiometer is basically a variable resistor, right? So we're going to next use a potentiometer, but before that I'm going to give you all exactly 2 minutes to post your circuits in Discord if you all have made them. Or if you all are facing any issues, let me know. We'll slow down and I'll redo the entire circuit process. Because I see no comments, I'm going to wait for you all to catch up and just make another circuit for the sake of it, right? So let's do this. Let's stop the simulation. I'm going to go here. Resistor. This time I'm going to put a lower value of the resistor, around 5 ohms. Passive activity. Second passive activity. And this is going to get 1 by C. Is anyone posting? Is anyone trying the circuit? Sure, I'll just explain the entire circuit's working again. So where what the start simulation is doing is basically it's letting you interact with the circuit, right? So if I push the button right now, nothing will happen because right now it's more like an edit mode. Start simulation will not let me edit the circuit anymore. And when I click on the push button, you can see that the LED here is glowing. So if you observe the LED here, it will start glowing when I push the button. And if I keep it pushed, it will keep glowing. Awesome. We got it. Hello, Ashish. Please focus on your college. I'm a little concerned about you right now. And Ashan, I'll just explain the circuits working again. All right. So what's happening is, okay, I need to figure out how to control this better. Okay, so this is your power giving component. Okay, a battery is your active component. It's giving power. All right. All the rest of your components are passive components. A switch does a very simple thing of shorting your circuit, right? Have you all ever seen a switch work? A switch is nothing but two terminals. Okay, I'm not kidding. Switch is something that you all can make yourself. You all can just sit down today, get some copper tape, get some metal, and oh yes, it does. The capacitor does look a lot like the LED, but in real life, it's very different which is why way you can differentiate it very easily. Did you use the capacitor by mistake the way? Is that why you're confusing it? Anyway, right? So your battery, it's okay. It's a story for you to tell in your next stream way. I look forward to being mentioned. But yeah, so here's the thing, right? This is your positive end of the terminal, this is your negative end. All your positive ends get connected to one side. So you always connect the positive end to the positive end and all the negatives to the negatives. So how it works is your switch is one of the simplest components around. All right. So how does a switch work? There are two metal terminals, and there's a one metal terminal that's suspended above. This is not kid. I'm not kidding. This is the real. This is how the switch actually looks like if you open it. Okay. Hi, Alvin. Alvin is another one of my favorite hackers who's back. But okay. So right. So there are two metal surfaces, and then there's one suspended metal surface. Now, how does your circuit work when all of your wires are shorted? Right. So what the switch is doing, it's keeping the entire circuit open until you press that button. As soon as you press that button, your entire circuit gets completed, and the current starts flowing in your through your because of your battery, right? So that is what happens to a switch. Next is your resistor, right? What is a resistor? It's basically something that helps you limit your voltage, right? Again, why do you use a resistor with an led? To you know help you not damage the led. Hi, Salarmu. Please don't call me ma'am. I'll have to call you sir back. So, yeah. All right. Fun stuff, right? So, your voltage starts flowing. You short the switch. The voltage starts flowing. It goes through your resistor. The resistor limits the voltage a little. Then the voltage hits your LED. It absorbs the voltage, glows, and sends back the rest of the voltage which it doesn't need. So the voltage difference will depend on the resistance and the current of the circuit. So if the LED's resistance, its internal resistance which it's consuming, is, say, I'm going to give a very bad example, so I'm just going to say like it's like 5 ohms, and the current going through is, say, 2 amps, it's going to consume 10 volts, right? V is equal to IR, so it's going to consume 10 volts. That is how you calculate the battery of the voltage. So over here, you know that the entire circuit is being powered by 3.43 volts. That means your entire voltage consumed is less than 3 volts in a given circuit at the very least, right? Is that so, Salad Mama? Which channel are you trying to post in? It worked. That's awesome. I'm so glad to see that. Beginner Lounge. What's your Discord channel again, Salad Mama? Let me see if I can do something about it. I'm so glad you got it, Ashan. Again, if there's anything that I can again help you learn, if you all want me to break down the LEDs internals or the resistors internals, we'll do that. That is weird, Salad Mama. What's your Discord? You know what? I know your Discord ID. Let me just quickly look into that. Okay, I'm sorry I lost the channel I was sharing earlier. Can you please tag me again in that channel? I shall. That is weird. Let me look into this. Can you all just tag me in your guild channels? I will look at your Discord IDs and look work it out right now so that y'all can post. Y'all are doing great jobs. Y'all should be able to post. Beginners week launch. I have a feeling the reason you all might not be able to post is because you all haven't checked in. Is that it? Let's see. Let's see. Can you just tag me in your guild channels? I will definitely look into it. Awesome. That is amazing, A Jackson. That's the exact next thing I was going to tell you all. How do you measure the voltage and the current flowing through your components? That is awesome, A Jackson. A Jackson, would you like to join the stream and show folks how you did it? I would love to have a hacker come and show it on the stream. Can you all please just tag me in your guild channels? I'll definitely look into this. Here, this is what I assumed was happening, that you all haven't reacted. So if you all go to this channel and react, you should be able to post in the beginners lounge. All right, let's see if you have the role or not. So, Ashish, I do see you do not have the Global Hack Week January tag, which means you haven't reacted to the GHW role. So, I think that should be. I'm just gonna tag the channel for you. Hack Week. If you all go there and react, oh, I see Salad Mama having posted in there. It's okay. That is awesome. Hack Week. And here's what I'm gonna do. I'm gonna go in Beginners Week Lounge and tag. All right. I hope that helps. Amazing. I know it. Salad Mama, I've sent the channel name, so you should be able to now click on that channel and react there. Awesome. I hope it's working for a lot of folks now. It's all right, Ashish. Even I'm coming back after a long time. I'm sure in my next FPH, you all will be teaching me what I need to do. So you're good. All right, folks. That is amazing. Hey, Jackson, I still waiting for your answer if you want to come on stream and show how that works. If not, I'm of course going to do it. But awesome, it's working for everyone. This is great. I'm glad we could solve this. All right, so let's now look into how do you measure how much current and voltage is actually flowing through your components. I don't know if you all ever did this in high school, especially in 9th, 10th in India. We used to have these numericals, right? And when we were taught the concepts of electricity, and the numbers were crazy, right? I mean, I look back and because we were small kids and we were still learning a lot and we didn't understand a lot of concepts. Our numbers used to be 4 amps is flowing through the led, and the resistance is 20 ohms and stuff like that. Okay, now of course we got the answers. In hindsight, you realize how unrealistic it is, right? So a Jackson here actually did get us the real values. I'm just trying to find his current, and he's gotten 1.16 milliampere. Now, a Jackson, I don't know what's the resistor value that you used, but now we will also measure here, right? So let's go here and find our DMM. Now, I'm not sure what it's called here. There we go. There we have a multimeter. Awesome. I'm going to remove this and let's do this. So we have a mode, right? So we can measure multiple things. I'm going to keep it on voltage for the time being. Now, can anyone tell me how do I connect the multimeter in my circuit? I am not sure. I think you should be able to join, but according to the edit profile, I don't think you all will be able to join multiple guilds. Good night, Senior. Have a great night. I honestly don't know. It worked. Oh well, I guess not. Then not. That's okay. You hook it. So that's the thing. Multimeter, you can hook it in any direction. The problem is how you hook it in which mode. So I'll tell you why it's important, right? Before and after the resistor, yes, if you want, so before and after the resistor in parallel or in series. That was my question. Good night. Will you hook up to measure the voltage? Will you hook it up in series or in parallel? So you can change gears every 24 hours. That's cool. If you all want to be a part of uh, I have a very bad joke here. If you all know how LED brightness works, this is basically you all doing this. So what happens is LED brightness is controlled by analog switching. So if there is a circuit which does not have analog output, what you do is you use digital output, but you switch it very quickly. So you do 0101 very quickly. So it looks like the LED brightness is changing, but really it's just switching between two modes. And I feel like that's what you're going to do in guilds if you change every 24 hours to be part of two guilds. In parallel for what? Current or voltage, Salad Mama? You have to connect it in one way each, but which for which? So how do you connect it for voltage? Is it series for current? All right. Series for current according to A. Jackson. You know what? We'll try it. We'll try it and find out. Okay, so here's what I'm gonna do. I am gonna quickly go get some water for myself, and I'm gonna give you all exactly 3 minutes to figure out how it works. All right. So when I come back, I want everyone's DMM multimeter. DMM is digital multimeter on their Tinkercad, and then we're gonna try out all the four ways and see how it works and why it works that way. All right. So I'm gonna be back in exactly 3 minutes. I will see you all in 3 minutes. All right, folks, I am back and I see there's a lot of discussion here for parallel with bulb, parallel to the LED for voltage. All right, so Do you all remember galvanometer? If you all ever studied that in school, has anyone studied the galvanometer? So I'll tell you why I remember it differently. Now I could be wrong, but let's find out, right? So correct me if I'm wrong, right? So okay, so everyone studied galvanometer. That's awesome. So your multimeter, especially your digital multimeter, is basically your galvanometer being connected in, a certain way, right? Here's what I remember, right? A galvanometer is extremely sensitive, right? So if you want to measure the current, now here's what will happen if you connect it in the circuit for voltage. What will happen is your entire current will go through the galvanometer and it gets damaged. Instead, what you're supposed to do is if you connect it in parallel for the current, you get the accurate current going through the galvanometer instead of the circuit, and that's how you get it. Now that's what I remember. Am I can you all tell me if I'm correct or wrong? So anyone, A Jackson, since you're so, since you already measured it, right? You measured parallel for voltage, which makes sense, right? Which is how you get the value. How is it different? How is it really working? All right, so I'm going to connect my multimeter here, right? Let's connect. First, let's connect it. It's in voltage. I'm not going to change the name. I'm going to connect the positive end to the positive end of the terminal. Uh, there we go. Let me get it here. Connect the negative end to the negative end. Flip this where I can. And then enter stimulation, right? Now this is showing me the correct value. So how is it working? Anyone? My question is, if the galvanometer is so sensitive, right? And your multimeter is basically your galvanometer in different ways. You're just shorting it in a different way. How is it that when you're connecting it in parallel with the voltage, it's not getting, it's not getting destroyed? It does, which is right. It's correct. So your multimeter should be in parallel for voltage. That's correct. But why series for current? Anyone? The reason I ask is it's a very nice theory, right? I've always loved playing. It is. So now let's change our uh let's stop the simulation. Let's change this. Delete. So I'm gonna let the negative end be at the negative end, and we can just keep changing the thing. So let's go here, put it on resistance, delete, negative end, negative end. Let's start simulation and 0 volts. Now when I push the button, I see that the value is 1.28 volts. All right, so remember this, folks. There's 1.28 volts. I'm going to add a note right here. Okay, there we go. So I know that my value of resistor is 1.28 volts. All right, next I'm going to delete this, delete this, connect this here, connect this here. Now remember, I'm always connecting the positive end to the positive end, which is why I'm getting positive values here. All right. Now remember, this is 29.4 millivolts without any current passing. All right. This circuit is basically open right now, and there's still some voltage. All right. That is an amazing answer. This is exactly what I was looking for. The reason I asked this was because when we now can start connecting LEDs and components in parallel and series, this will really help. why are we doing this? But that's awesome. So here's what happens, right? When you connect things in parallel to a battery, the voltage given to all of them is the same, but the current gets split up. The current is different, which is why you never want to connect your multimeter measuring current in parallel, and you never want to connect a voltmeter in series because the voltage drops across the series circuit. Does that make sense? That is awesome. This is basically what I wanted to get to by using the galvanometer, but I'm glad you just gave the answer. But awesome. So let's close the switch to see it. I know A Jackson is like, let's just get to this. Okay, 1.72 volts. Let's add a note here. So 1.78, 1.78 volts. Awesome. Let's run the simulation again, verify it. 1.72 volts, my bad. One. It won't let me edit it. I need to stop simulation. 1.7. All right, so 1.72 volts. Awesome. So now we have our voltages. Now let's look at our currents, right? So I'm going to remove the shortings right here. Delete, delete, delete. Next, we're going to connect 8 in series. See our current. Start simulation. So our, oh, never mind, my bad. I haven't changed the mode. So mode, amperage, which is the zero point 0.0 amps. Why? Because there's no current flowing. That is a good suggestion. Also, I forgot, before going away, I saw the circuits that everyone is posted, and I see Ajax has done a beautiful job creating this circuit with it being very neat. Anurag, however, has made a real circuit. If you all want to go out and check it in the Beginners Week Lounge, people have done an amazing job. Some people have gone ahead, created it very neatly. Some people are like me, they just made it. It works. Great job. Good enough. And people have actually made some beautiful circuits. That's awesome. All right. So it's not ending yet, Ashish. We have still some time to go. We're gonna check all the currents. We're gonna see how the calculation works. All right. We have a good 15-20 minutes left. Right. All right. Great. So let's check our ampage. So it's 0 amps right now. It's 128 microamps. Can you all imagine that? That's how small your current values are. Okay, so I'm going to put here, it is 1.28. Because I don't have the mu symbol, I'm going to put microamp. Start it again because I have a feeling I remember it wrong. 128. Okay. 128. So here's what I'm going to do. I'm going to remove this and I'm going to do 0.12 milliamps. All right. That's your current. All right. When there is the initial current, right? Now let's go on and delete this, connect this back. And now we're going to go ahead and put our meter here. So let's go here. There we go. And let's start simulation. 0 amps, and over here it's also 128 microamps or 0.12 milliamps, which is great, which makes sense because there's no drop across the switch. The switch ideally conducts the entire current, and there's no voltage drop or current drop across it, right? Again, ideally there's metal in it, so there's always some form of loss happening, but we can go for the ideal conditions right now. Positive, negative. Let's start simulation. Let's press. Again 128 microamps, which verifies that your resistor has a voltage drop and not a current drop across it, right? So the current has remained constant, but the voltage has definitely dropped. We can see that, right? Awesome. So we have, again, let's check 128 microamps. That is awesome. Now let's remove this. Delete, delete. Let's delete this. Awesome. We are done. And the last time we're checking this, what did we understand by this? Enough to try and use a simulator before I go on to actual LEDs. That is such a great example, A. Jackson. I'm at this point. I'm pretty sure A. Jackson can run the stream better than I do. But that is correct. So what did you learn, right? So that verifies my initial question of why I asked whether the multimeter goes in series for current or in parallel, right? So if you want a soldering kit, especially if you're starting out for the first time, I suggest using Robo or you know Robo Craze in India specifically. Amazon has great options worldwide, of course. Don't go for Amazon the first time because you want to be able to, because soldering guns irons can be very weird in behavior. Like they they burn fast. For example, because I know when to stop using it. I get the cheapest ones in the store, which cost me around 150 rupees, which is less than $2, and just keep like a bunch of them at my place and just use them because I also take a lot of workshops. But if you are going it for the first time, make sure you get a good quality one and that you can count on it, rather than just once you understand the behavior, you can always go for that's the best way to learn, isn't it, A. Jackson? No worries. I hope you all have also used the DMM, the multimeter. It's a really good tool going forward once we start designing circuits. Yes, you can get an electrical shop. Again, make sure that the electrical shop is accountable, especially if you're buying it in India. It can get very dangerous very fast. Sure. So robo.in. Let me quickly drop the name. So it's Robo, and then there is Robo Craze. Both of them are interesting websites. Thank you, Alvin, for sharing the check-in link again. Yes, please check in if you're here. Y'all have done. Y'all deserve the swag. All right, folks. So I would like to cover a little bit more about passive components, so we can go back to the PPT and start discussing again. But if y'all want to right now take the time to play around with the components here, let's do that. That is a good suggestion, A. Jackson, but at the same time, I do not recommend anyone using more than a 25 watt, especially if you're starting out. 25-watt is good enough. So I right now have 10 kilo ohms set for my resistance way. And you know what? That's a great question. Let's because we know that the current is staying constant. Let's try and change the resistance value and look at the voltage. So I'm going to delete this, short this back, and put our voltmeter between here. I'm going to first start the simulation and check the combined voltage, which is 3 voltage Start simulation. So there we go. It's 3 volts, obviously, because that was where did I paste it? This is bad. This should be better. All right, so it's 1.72 volts. Now I'm going to change the resistor value and see if it makes a difference, right? So let's make this very significant amount. So start simulation, 1.62 volts. So there you go. That's the amount of change that can come to your voltage. You can keep changing it and playing around with it. Let's make this 500. See if it changes 1.55 volts. So you can see a pattern coming there, right? So I had it at 10 kilo ohms, right? Right, 10,000 ohms, correct. 10 kilo ohms, A. Jackson, right? There we go. Priyanka has a great suggestion for people living in Noida. So it won't burn. It never burns. That's the thing. It depends on your LED, really. I'll show it to you. I mean, I do it all the time, especially when I'm testing LEDs, right? Let's do this. Start simulation. And there you go. So it won't, but if you see, it's much brighter way. So the resistance is really, helping you control the. So here's a better way to do it, right? I'm going to delete this resistor and I'm going to add the thing that I was very excited to show you all about in the first place, right? So here's what I'm going to do. I'm going to terminal 2 goes here, terminal 1 goes here, right? There we go. And the middle terminal. Okay, this is better. And my middle terminal will go to my LED. And there you go. Perfect. So now what I'm going to do, so this is basically a variable resistor array, and now you can change the resistance by just, changing the, and you can see how the brightness varies from zero resistance to highest resistance of the potentiometer. And I am pretty sure I can set the range of the potentiometer as well. So my resistance can be from 0 to 500 kilo ohm, like we saw, right? So let's do that. Here's what I'm going to do. I'm going to change the switch type to slide switch so that I don't have to keep pushing it. So I'm going to take this. There should be a different kind of switch as well. Let's search. Switch. That's okay. This is the one that we have. So we'll just use this. And we have terminal 2, common, and so it's terminal 2 goes to positive. Terminal 1 goes here. And I should be just able to slide it. Okay. So let's start simulation. That's our voltage. I turn it on. Okay, my bad. And the common goes to negative, of course. So there you go. There you go. This should make more sense. There you go. Now I'm going to start the simulation. What am I doing wrong? This is weird. Okay, I'm going to figure out why my circuit isn't working. Are you sure? I'm pretty sure it's not because you connect the common and then you keep shorting the different kind of All right, let me try saying doing what Alvin is asking me to do. So I'm going to stop the simulation. I'm pretty sure I remember it being like this, but so you're saying the middle one. I did send the middle one to negative, right? Hmm. It's okay. You know what? I'll figure this out for you all tomorrow and see why this didn't work for me. But until then, I'll just use a push button because I don't want to confuse folks more. And there you go. And I'm going to start simulation. You know what? I think I've connected the potentiometer wrong because it's all flipped. Nope, the potentiometer is correct. So anyway, let's look at the potentiometer. That's the whole point of here. So you can see as I'm increasing it towards the positive end, the resistance, if the voltage is increasing, that means the resistance is decreasing. So at this point, it's close to 0 volts. And as I increase the resistance, this is my 500 ohms. And this is something what we saw, right? 240 millivolts. And yep, so this is your variable resistance, and you can always set the range over here to as much as you like. So let's click on this stop simulation, click on it, and you can always keep increasing or decreasing the range of your entire resistance. I think so too. You know what? You're right. I'll just figure out the slide switch right now. But does that make sense? The way I hope I answered your question regarding the resistance, right? So you're basically just changing the brightness. So I usually show this in person as well. I have some LEDs right here. What I might not have is a battery. So I'll show this to you in the next time. I have some passive components right here. Or it's in case you all want to see a potentiometer real time. This is how a potentiometer looks like, the one that I use. But I would love to show you all, how I just literally can just short the battery. Alright, anyway, next time I guess. I'll keep more components ready. I had the passive components ready to show you all here, but then I realized you all already knew a lot, so wasn't necessary. I think you thought more Jackson than you learned, but I'm glad. All right, folks. I am gonna quickly close the session for today. Like, I'm gonna stick around for another 10 minutes because I know Karuna has an amazing Bash scripting session prepared for you. Uh, I'm glad you enjoyed Way. So what we will do in the next time is we'll talk about active components. We'll do all the same activities we did this time, right? Analogies, and we're gonna go around the house finding active components. It'll be much easier because almost anything that you all see around will qualify for technically an active component. But I am expecting something like Salad Mama did. I don't think I shared the screen properly last time, so let me do that. They actually went up and showed the capacitor in the fan, which is very impressive. Huh. If I only find the channel in time. Hmm. Okay, I'm gonna find the channel in a bit and keep it ready for the next stream. But so yeah, we will do fun stuff tomorrow. And if there are Salad Mama's right here. Which channel did you post it in, Salad Mama? I can never find the right channel in time. You should see me, when I'm judging in FPHS, it takes me forever to find the judges channel. I always lose channels. uh but I'm glad you all enjoyed it. So this is what I wanted, right? Which is why today was a very unstructured session. But now I know what you all enjoy and what you all don't, where you all want more focus. So next time I'll have some more things prepared. And the last session, we'll actually sit down and make an entire project together, right? We'll figure out a problem statement, and we won't use actual sensors. We'll try and use simulators for so that you all have a better prep for that. And yeah, free and open source community united. All right, let me see if I can find it in time. Found it. Awesome. So let me share the amazing thing. Okay, stop presenting. Present. Share screen. There you go. So this is what Salad Mama went ahead and shared, which is very cool, right? So I expect you all to put this amount of effort tomorrow when we're looking for active components. And while we're at it, I see some amazing Ajax again here did crazy job. Like this is amazing. Then Nanarag actually went and made a real circuit, which is also very cool. And over here I see tons of amazing circuits. Great job, folks. I'm so glad you all did this. And yeah, that's it. So I'm going to stick around for another 10 minutes if you all have any questions. We have some, yeah, we have exactly 10 minutes before Karuna might want to, come and start preparing for her session. So let's hear if you all have any questions, if you all have any suggestions. That's a great question. So, way what's happening is what you're basically doing is you're making a tiny circuit yourself. So, what you're doing is you're connecting your voltage. So, you're giving the resistor entire voltage. Then you're giving it resistance. And so, the middle terminal is where you're, kind of it's getting the resistance after it's getting the potential after it goes through the resistance, right? So, imagine your variable resistance, right? I don't know if you've seen those big variable resistors. They're called something I cannot remember, but they're like huge, and you move it. This is exactly like that. So what's happening is basically your first and third terminal, you're giving the entire voltage. Your middle is where you're getting the voltage after the resistance. But to be able to give the accurate resistance, you need to give it the full potential to the both the terminals. Make sense? So you're giving, again, you don't have to, you can always connect it in circuit, but then it kind of kills the point because your potential will be limited to the voltage that you're getting right there. So when you're connecting it in parallel, you're giving it the entire voltage of the battery, and then you're giving it the potential after it passes the resistance, and you're giving it more range of voltage basically. I hope that made sense. Awesome. Great. So all your volume buttons, by the way, y'all could have sent me pictures of that as well when y'all were giving me passive components. Y'all still can, by the way, go ahead and post it. So your volume buttons in your systems, your theaters, anywhere for that matter, the one with the rotate or your fan voltage regulator, they're all passive components. They're basically variable resistors because like you control the brightness of the LED over here by controlling the potentiometer. You're basically doing the same thing. You're regulating the voltage that's going to your component, even though it's AC in this case. It's a passive component, and it's very cool. So if you all want to still quickly go grab a picture of your home theater button, and then I do have rotary encoders, but if I showed you the mess that my electronics box is, so like I have like three different like boxes. Everything is like filled with electronics, and there's a huge box right there. So how about you do this? You all give me the components you all want to see. I'll make sure I keep them out. And I'll probably change the direction of my table because this is just I feel like I'm at some point doing some kind of experiment with the camera and its lighting. So I'll keep it out. So here's the thing, right? It depends on what you mean by power consumption. Your resistance is changing. You're not changing the. So again, over here, I'm not exactly consuming less energy from the battery when I'm increasing the resistance, right? I'm just changing the brightness. So I'm consuming the initial energy I'm just regulating it in the middle and reducing the flow of it just to the device. Makes sense? So even if you keep it at a lower speed, you're using the entire energy that a fan would ideally use. What you're doing is you're just sending a less amount of it to the fan by keeping a passive component which uses up most of its energy. Make sense? It does. How are you saying that? I mean, I agree with Salad Mama here because you're using basically the same amount of energy. You're just resisting a lot of it on the way. Then now you know. All right, folks. It is 12:17, so I'm gonna stay here 3 more minutes so that Karana has a good 10 minutes to come before and prepare. Exactly. Exactly. So your voltage, so your resistor is basically dropping voltage. What it's doing is by increasing the resistance. It's so if you notice, right, in any of your electrical devices also, the rating, right, the specifications is never current and resistance. It's resistance and power. So what you can do is you can always assume or calculate the current it will use. Makes sense? So depending on the voltage, because the voltage might change, you can calculate the current and hence then the new power that you're actually consuming. So if you look now, if you take out the bulb or whoever posted the bulb's picture earlier, if you look at the specification, it will have the resistance and the power, not anything else. So the IR, exactly. Awesome, folks. If I don't see any other questions coming in, tomorrow morning, wait, tomorrow morning's the next session. An hour earlier though. Although I think I might negotiate the timings a little because it's too early for me. But yeah, it's 9:30 a.m. IST tomorrow, which I think is 11 p.m. EST. Yeah. Awesome. I'm so glad you all enjoyed the session and so many of you all stuck around till the end. I know. I know, Abhay. Trust me, it's too early for me too. My parents were surprised and very happy today to see me up before 10 a.m., 11 a.m. In my defense, I do work late, so I'm glad it's relatable. I don't know if it's healthy though. I would like to change eventually, but thanks, Way. I appreciate the acknowledgement. All right, folks. I am going to. That's okay, Salad Mama. You can always watch the recording, and we'll try and catch up when I take an FPH. I know I'm staffing the next FPH in February. The exact dates I'm not sure yet, but I'll let you all know. That is so cool, Hanan. I would love to be a 4 a.m. waker at some point. Alvin's always there in my streams. At this point, I don't even know if Alvin actually means this, but where's Ellie? I miss Ellie. I thought Ellie would join as well, but that's okay. Thank you, Way. We gave it in all the possible time zones. All right, folks, I'm gonna close because I want Karuna to have a good 10 minutes to prep. And yeah, awesome. I'll see you all tomorrow, and we'll create new circuits and learn a lot more. Bye bye.